Hello, everyone. Thank you for joining us today. My name is Michael Henry. I'm the Vice President of Growth Strategy here at Drummond Group. I'm pleased to welcome you to this webinar on identifying and eliminating code-based PHI and PII data leak risks. Today, we will be speaking with executives from Next.sec AI. On the agenda today includes an introduction to our guests, followed by discussion about the risks of data leaks, why you should not ignore those risks, how you can detect and protect sensitive data, a comparison of the traditional approach to data protection, and proactive code scanning. We will follow that with a live demonstration of Next.sec AI's sensitive data protection solution, then end with a question and answer period. During the webinar, please use the chat function found on the right-hand side of your screen to comment or ask questions. We will address as many of these as we can at the end. We have a lot to discuss, so I'd like to get started and like to welcome Assaf Amitay, Next.sec AI's Chief Executive Officer, and Dr. Uzi Haddad, Next.sec AI's Founder and Chief Technology Officer. Welcome, gentlemen. Assaf, would you like to introduce yourself first?
Hi, Michael. Thank you, everyone, for joining today. My name is Assaf Amitay. I'm the CEO of Next.sec AI. We're privileged to present today our system. I bring along with me a vast experience in the high-tech industry with a focus on privacy and security. I served as a senior management member of companies like Checkmarks, Checkpoint Software Technologies, IBM, worked as a McKinsey consultant in the past. So all in all, I've seen the world of privacy and cybersecurity evolving all the way back from the days of just facing network issues, later on to the revolution of the cloud, and now, of course, the hot topic of AI. We're going to present all of that today. Thanks again for hosting me today.
Uzi?
Okay, thank you for the invitation and being here. So my name is Uzi Haddad. I'm the CTO and co-founder of Next.sec AI, coming with a long background in engineering, big data, data science, cybersecurity. I hold a PhD in mathematics and computer science from the University and a postdoc from the Weizmann Institute of Science. Thank you for being here.
Absolutely. Great. So perhaps we can jump right in and start with the cost of a data breach. We all hear quite a bit about a wide range of sizes and expenses and the repercussions of data breaches. And these can vary quite widely by industry, but I think it's interesting to highlight specifically when individuals PII or PHI is involved, that the average is just under about $5 million. We hear about some of the larger data breaches that may impact organizations from a ransom perspective or disrupting operations, having a bigger impact. But in addition to those types of breaches, when there is PII or PHI involved, there are additional repercussions as well. And this cost is not just limited by the fact that you may have lawsuits from the individuals impacted, but you may have fines as well from the regulatory bodies that oversee, the various industries or your company that also add to the damages. Uzi, Assaf, maybe perhaps we should start though with what is data leakage? What is impacted and why is this important?
So that's a great question. So data leakage is eventually, it's simple to identify in the sense that this is an unauthorized transmission of confidential, sensitive information, proprietary information that eventually is leaking from the organization to the outside. It can happen due to human error, and the slide is already telling this is usually the case, or it can stem from various ways in which attackers are trying to extract that information from the organization. Now, different types of information can leak. In the worst case scenario, it can lead eventually, there are some rare examples like that, to a complete destruction of the organization. Think about it, right? The most obvious parts are reputational damage, lawsuits that you have mentioned before, and things like that. But we live today in an area, and this is where now it became almost a cliche slogan that data is the new gold, or that if nobody is charging you for anything, you're the product. So people are getting more and more aware, and they're becoming very sensitive to the fact that their information is out there. And the preference nowadays is to make sure that we are not as easy as we used to be in the past to allow organizations, services, products to freely use our information, because we are much more aware of the consequences of what exactly does it mean. So if we frame it for a second, the leakage means that I trusted, whether I'm a customer as an individual or organization, I trusted another organization to properly treat my information, the confidential information that I very carefully deposit in his hands. And eventually the leakage means that the information, for one reason or another, was actually finding its way to the outside world in, let's call it, an uncontrolled manner. There are many ways to try to tackle that. There are many ways to eventually to try to prevent it. We're going to elaborate a little bit more about that later on. But I think that one piece of info that is very relevant and important to state is that automatically when we hear about data leakage, all of a sudden, especially all of us here, the savvy executives and the representative of other companies or here on the call, we immediately think about the direct financial implications, the fines. You've mentioned almost $5 million. This is a grave outcome for organization to be fined, but this is usually just the tip of the iceberg. Again, one can think that the extreme can be a complete devastation to the organization in so many different fronts. This is why it's very imperative to eventually to take the right measures, to find the right balance, of course. All companies would like to be profitable and not just to put a lot of fences and eventually to lose money. But finding the right balance is super important, especially when you put on the weights the potential consequences for such a leakage.
No, that makes a lot of sense, and I appreciate you highlighting those other factors and repercussions of a leak rather than just the financial. You're right, and some of your euphemisms that you made earlier, those comparisons, I wasn't familiar with, so I am definitely going to borrow those for future conversations. Maybe a good question though, to the point that you raise is, how do companies address this today, and do these practices always work?
So maybe my colleague Uzi is going to give a very detailed explanation about the different methods, but I do want to maybe to add the two last sentences on the previous questions. The first one is that these days, and we are part of a revolution now, whether we like it or we don't like it, the AI is bringing a lot of benefit, but also is dramatically increasing the risk in the topics that we are discussing right now. It's worth giving it the right attention. And secondly, there is a good reason why certain industries, healthcare, financial services, and the like, where I know that Drummond is very busy, and specifically in those topics, that those specific areas are very heavily regulated, because the specific implications and the sensitivity of the data, usually in those domains, in those verticals, we can take everything that I've just said 1 minute ago and probably multiply it. There's one thing that your name is leaking, and it's completely other thing that your medical information or your complete financial information is being leaked. And this is why in specific areas, specific industries, everything that we've just covered is getting an even very high enhancement. Therefore, there are many key practices in order to try to solve the problem, and this is where we're going now to elaborate what is in it right now and to where the market is going. Uzi, please go ahead.
Thank you, Assaf. Yes. So the first thing that you need to do to be prepared for data leakage and also to prevent data leakage is the first step is the data classification, data mapping. And this is a fundamental part for every company, in particular companies that develop their own application, and to have a good mapping of all the PI data store, third parties, machine learning, AI, data flow between the services, communication, and etc. So nowadays, there are several practices. The most common are the following. The first one is to do manual mapping by questionnaire, by sitting with the engineer, ask them questions, send them questionnaire, fill in form, and then based on that, get some kind of visibility about all the data, where it's stored, where it's flow. And this is, as you can imagine, a very cumbersome, very time intensive, and no one in the engineering really have the power and the willingness to do that. Another option is the usage of data database scanning, that we're going to elaborate about it in the next slide. But the data mapping is as we said, is the first part. And then after data mapping, there is the need to provide and manage all the access control to your storages, to the cloud services, to the third parties. And then on top of it, there is a need to validate that the data that you store in the data stores are encrypted. And there is a regular update and patch management, which is very, very painful process. And then you also need that the engineers and all the company employee should go through training and to be aware of the fact that your company is collecting personal and PHI data, and all the process to protect the data and to keep the data in good place, and to delete the data if it's needed, and only to keep data if there is a real consent, or if there is a contract in place, if there is a real need. And this is a very challenging and painful process to do it in a manual way. And last but not least, the data is not only in our data store, it's also going to third parties. So you need to first to map all the third parties that have some kind of access to your data, and then also do the vendor risk management that we all familiar with.
Michael, maybe to help frame it for a second, this is how I usually think about the entire topic. It's eventually, I think that the multiple solutions here are highlighting the complexity and how problematic it is eventually to keep your crown jewels properly protected. So there could be different dimensions. One dimension is even to understand what is my sensitive data. It sounds very trivial, but in many cases, it's not as trivial as that. The second element is to understand, once I identify to myself what is the sensitive information, to understand where it sits. Once I understand where it sits, now I need to allow only the relevant people to access it, exactly as it's being portrayed on the slide. There are many other magics that one can put on top of that, the encryption and let's call it additional traps to people who are trying to eventually to get my information. And last and not least is eventually to increase the awareness. Good privacy and protection of sensitive information is eventually a combination of everything. One of the key elements, though, is that alongside all the potential solutions here comes also the complexity, the following complexity. A, it can become a very costly process. None of us wants to do that. Eventually, we're in the business of a positive ROI. And secondly, it's a complexity, even putting aside the cost related. We're living now in a world where all of us, I can speak on behalf of myself, I'm sure that you will resonate with that, we are all short-handed. We always have some scarcity of resources, and we never have enough time to deal with all our problems in our daily job. So what we want to make sure is that eventually you're coming up with something that is fairly simple, not that expensive, that will give you the best ROI out of all those different elements out here. But as one can see, this is all but a simple problem. If it was a simple problem, we all would have probably discussing a completely different topic.
Yeah, and I think one of the things that is very apparent to me is you have all these practices, and even if you are doing them perfectly, you still have that human element. And I know I've seen a lot of different data reports, out that have all highlighted how 70% of data breaches are based on human error, 90% are based on human error, and I have to imagine that those are really breaches. Let alone when you have leakage, which is similarly kind of accidental, if you will. So that makes that only further amplifies the problem because that human element is pretty considerable. So if we were to take this a step further, how does Next.sec solve this problem? And I guess how is this, aside from just being different from these key best practices, how how is it different maybe from other solutions that are out there?
Yeah, very good question. So, as I said before, there are two main practice nowadays that are very common. One is to do all the data mapping, all data discovery, and then the enforcement of the policy in a manual way by interviews, by questionnaire. The second option is to use a database scanning solution, which requires access to the data stores, to the cloud services, and other storages. And this is one of the well-known solution, but it requires, because it requires access to the data store, because it requires access to sometimes to the data store in the data in production, it becomes very cumbersome and very expensive. It's expensive in the sense that it might affect the performance of your data store. It's expensive in the fact that you need to provide access for every data store in your environment. It's expensive in the fact that it just gives you a point about, okay, there is a PI data in this place, there is PI data in this place, but there's no way to understand the context, to connect the dot, what is the process, what is the data leakage. And it also doesn't give any information about the integration and data sharing with third parties and with AI and machine learning. So at Next.sec, we come in with a different approach, a new approach. So instead of scanning the data store or doing the manual questionnaire, we scan the code. And in the code, we are able to detect and classify all the data mapping from source to target. So it means that we are able to classify that there is a PI data coming from this service, going through another service, and then it's going to be stored in the following database, or going to be shared with the following third parties, or it's going to be used in a specific AI model. So we provide a lot of context and information. We give a visibility about the flow of the data, and everything is done automatically without any effect on the production. Very lightweight, no agent is required to be installed. It's done as part of the CI/CD, so there's no need to add and to upload your code in a manual way. And we do it more proactively. So you integrate our solution. We automatically scan the code. You can define it every week, every month, whatever is recommended according to your company policy, and automatically the user get notification about changes, about tweaks, and get a very good visibility about the data. Going back to the first slide, it's mean that now you have a good visibility about the data. You know where the data is reside, and then you can add control and also enforce policies, control for access management, for encryption, and also policies. Let's delete this data because there is no use for the data. Let's delete this data after 90 days. This data should be encrypted in a different format. Let's isolate it between PI data and PHI data. So if, for example, all the medical data should be stored in separate data store, and all the PI data that connect between the user and his medical condition should be stored in a different data store. So we provide all this information in a very, very simple and a fast way using the technology of code scanning.
I want to try to connect it to the previous slide for a second and to put it into boxes. One benefit is the fact that eventually you are eliminating a lot of labor-intensive work. Labor-intensive work can stand for if you're using the questionnaires, then of course it's a very labor-intensive work, and also if you're using the database scanning, this is also a very painful, per what Uzi said, very painful and non-trivial process. So this is one element. The other element that you're gaining by this new approach is the fact that you're getting your results fast. And we're living in a world where none of us has any patience, and we want everything here and now. You're getting a full data inventory of your PII and PHI. We're going to show it in exactly a few minutes in the demo, within minutes. In the worst case scenario, an hour or two. If you compare it to scanning databases or to the questionnaires, that can take you weeks or even months. So that's another benefit. And the last piece here is that you have a full flexibility. You can get a real-time system in the sense that you can scan whenever you want, every time that you introduce something new to your system, or only once a week if this is your procedure, or only once a month before you have an audit, and you can decide whether you want to scan your entire applications, or God forbid, if you only have one critical application that is storing the most sensitive information of your, I don't know, a hospital or something like that, you can decide to do only that. So you have a lot of flexibility as a user on when to scan and what to scan. And per what we've said before, you're getting the results fast, you're getting the inventory of the PII and the PHI in a really fast manner. And maybe the last benefit that I want to state, usually when we have a problem, the best way or the best approach to address it eventually is not to patch it, but to try to handle it right from the roots. And we are dealing here with the code. For those of you who are familiar with that, it's the shift left approach, also very relevant in regular cybersecurity practices. It means that once you handle the problem and you eliminate the problem, you eliminate it right from the beginning, and from there your entire process, your entire application, your entire outputs are clean and without a problem. So you're not identifying a problem and you patch it, you actually eliminate it right from its birth, and this is a great advantage of our system.
Great. No, that's wonderful. Should we move on to a demo?
Yeah, sure.
Great.
So I hope that you can all see my screen. Let me start by showing an overall picture. I'm going to actually show a few snippets. The first one here is the outcome of the code scanning. And again, for what we've just said, the nice thing about our approach is the fact that you're getting a picture like that within few minutes, I'm sorry. This is eventually what we're seeing here. It may seem a little bit frightening, but I'm going to break it down. This is the full data inventory of sensitive information. And again, it's being produced in almost no time. What we can see here is the list of various applications that has been scanned. Again, the user, for what I've just said, has a full flexibility to decide what to scan. We can see here what were the outcomes of the scanning. The entire system, by the way, is built like an onion in the fact that you have layers and you can always drill down and get deeper and deeper, get more and more information all the way to the code. I'm going to show it. So here we can see that, let's pick up on a marketing service application that has been scanned. We can see that certain personal information has been found, sensitive information has been found, secrets has been found, third parties that are associated with that specific applications are immediately identified. And third parties, by the way, are a great source of data leakage, since our internal systems are speaking with the outside world via those third-party vendors. On top of that, and this is very relevant and much needed in the world of governance and compliance, using our own large language models, we provide automatically what is the purpose of what we're scanning and what is the main entity that is using that specific application. And again, all of that is being obtained within a few minutes and a very simple scan. The nice thing about the system is that it's very flexible for the user. I'll switch here to a screen that we call it the Explorer. This is a high-level view of all the findings that I've just shown you before, but in a cleaner and an easy-to-use view. We can see here that we identify personal information, the third parties that I've mentioned before, ML AI models, both internal and external. We're going to speak about it and to show how exactly does it work. This is a very hot topic these days. We can show the data stores in which the sensitive information is stored. And also, this is a blind spot in many organizations. We are identifying the relevant APIs via which there is a flow of sensitive information, and we can give a granularity of the information that is being shared. Nice thing about it is that I can go and actually search for everything in a very easy way. Let's say that I would like to look at emails. I can free text search emails, and all of a sudden I'm getting all the associated findings that are relevant to sensitive information type emails. I can filter the information here based on the regulation. We're supporting multiple regulations. We can tell you whether the findings might be contradicting HIPAA or GDPR or all the relevant regulations in the US. We can allow you to slice and dice the information. And on top of that, for each and every component here, let me pick up, for example, something else, let's say username information. The nice thing about it is that for each and every finding, we have the ability to eventually to click the finding and to get immediately what we call the ID of the finding, aka in what specific project we have this existence of a PII or PHI, what entities are using that, with what third parties the information is being exposed, what APIs are involved in that specific process. And more than that, and this is one of our secret sources, and we are very unique in this capability, we have the ability to provide what we call the data lineage, and this is what we see here. This is a graphical representation that shows the dependencies, the context of the findings, and the flow of the information. We can see here in a very nice graphical way. Let me pick up on one specific example. We can see certain applications. By the way, we can identify what AI ML models might exist in those applications. We can see exactly how and from where the information is flowing. In that specific case, information is going to Stripe, the financial third party. We can click, and I've mentioned before that everything is expandable, so I can expand here and see what type of information, sensitive information is being shared, payment information, and if I'll further click that, I can go all the way to the specific location in the code. And this is related to what I've said before. We would like to give the organizations with whom we work the capability to go all the way to the issue itself and to solve it right from the roots of the problem. In this specific case, imagine a scenario in which instead of going to, let's pretend that Uzi is responsible on keeping sensitive information in the organization, instead of telling Uzi, make sure that payment information is not being shared with external third parties, and Uzi will nod in his head and will say, okay, I'll try to do my best that this practice will be enforced. I can go now again to Uzi and tell him, listen, Uzi, in project number X, in line of code number 66, I know that this was not intentional, but sensitive information is being shared. We have to do something about it. Let's handle that. And then the nice thing about it is that for each and every such an issue, let me pick up another example. Let's say that I'm speaking about password information, an example that is being shared. I can go all the way and to expand it to the code, for what I've already said. We give the description of the problem. We give instructions or recommendations on how to remediate that. And on top of that, our system is also connected to the usual prevalent DevOps tools like Jira ticketing or Azure DevOps. So in a sense, once we identify the issue, it's very easy for somebody now to go and to take action on that and to eventually eliminate it again right from the source code, which eventually bring a very good and easy outcome to completely eliminate the problem. Just to summarize for a second what we've seen so far, so we have the ability to build a data inventory of PII and PHI and third parties and so forth within a few minutes. We have a sophisticated way to slice and dice the information and to research text it. Let's say that I would like to see something specific, or to look that intentionally that I'm not sharing now, I don't know, health records, so I can search specifically for that. We can go all the way to up until for each and every finding, up until the level of the code. We can connect the systems to the relevant development systems in order to remediate the problem straight from the code. And then there is one last layer that I want to show you. AI is a very hot topic these days, and we actually built on top of everything that I've shown so far an extra layer that is related to AI that allows you to do the following. It allows you to identify all the AI models that are running inside the organization. It may sound trivial, but I'm sure that you've all heard the term AI shadow or AI shadowing. This is exactly that. In all the organizations that we visit, usually we find that there are much more AI systems that are running than what the organization was originally anticipated. Why? Because the data scientists or the users, they are not waiting for anyone and they are bringing their own models. We can give you an holistic view on what we call the AI systems, which are AI applications or agents, became now the hot way to call it. So for those agents, we can tell you exactly what sensitive information might exist in the models. We're able to look inside the model itself and to find the vulnerabilities, which is super important if your organization is planning or already using, I call it external AI models, such as DeepSeek or alike. And the last true interesting layer here is that we've built also what we call an automated red team lab that allows you to stress test your models against the behavior and the anticipated outcomes that you're supposed to get from those models. So to try to summarize it again, we're showing you which AI models exist. We're showing you in the light of this webinar what sensitive information might be shared with those models. We're giving you a holistic view of the AI agents themselves. And then the last nice piece here is that we are also providing you with a very detailed framework to eventually be able to cope with the proper regulation demands. And we provide an almost fully automated ability for an AI reporting that allows you to give the proper attestation that is now very much required. I'm sure that you're all familiar with the EU AI Act It was declared in October 2024 in Europe. There will be similar regulations soon, probably all over the world. So by using our systems, you can map the relevant system and assess the risk and provide the right reporting around that. It's worth mentioning that we're not just doing that for the AI, but we have the ability to help you with all the so-called regular reporting, such as DPAA, ROPA reports, executive reports, and the like. And again, if we're going back to the benefits of the systems, you're getting these reports in no time, simply because the results of the scanning that we mentioned before are being populated automatically. And by that, we're ticking the box of automation. We're ticking the box of removing a lot of labor work. And we are ticking the box of accuracy, because we're able to take all the findings that we identify automatically and to plug them into the reporting. So you're getting a very detailed and highly appreciated report that can highlight and pinpoint all the possible problems that we've mentioned earlier during this webinar. I'll pause here for a second to ask if there are any questions.
Lucy, are there any questions? I do see some popping in, yes. Carmina. What are the main benefits of code scanning over database scanning is one of the questions that has come in.
Okay, so we touched it a little bit. Uzi mentioned that. And Uzi, feel free to jump in as well, but I'll repeat a few of the things that we've said. So the first one is the ability to identify the problems and the issues almost in a real-time scenario and right from the beginning. Think about instead of developing a very sophisticated application that is collecting sensitive information and externalizing it, and then start to try and find this sensitive information in the database after that, you can track all of that right from the beginning and eliminate that. So you identify the problem right from the start in a much easier way. It takes you far less resources, and your ability to eliminate completely the problem is much higher.
Yeah.
Also, for the technical people within the organization, it's a much easier solution rather than now to try to grant access to all the different databases inside the organization. Sometimes it's even a hassle or a big issue just to identify all the relevant database, let alone now to start granting permissions to start scanning all of them.
So let me add on top of what Assaf said. So here are the following benefit if you compare code scanning to database scanning or even to a manual process. The first thing, as Assaf said, this is the time and effort. With code scanning, it's done in a few minutes. With database scanning, it's very cumbersome, require access to the data store. So to scan all the repository, it takes few hours, few days. To scan all the data store, it's something between 6 months to 12 months. So wow. This is the first benefit. The second benefit is the fact that in database scanning, you don't get any information about the data lineage. You just get information about the fact that there's PI data in the following data store. With code scanning, we provide all the map of the data lineage. More than that, we also provide context, which service process which PI data and which service is storing data in specific data store. In database scanning, you need to do it in a manual way. You get information, you have a data leakage in the specific data store. Now the question, what are the sources? Which application, which code is using this data store? Who is the responsible behind it? So with code scanning, you get everything automatically. Also the frequency, code scanning, as Assaf said, is done continuously, automatically. Database scanning, because of the heavy lifting of the access to the data store, the degradation in the performance It's done more manual way. You need to test it, to validate it before you do it in production. And so this is another benefit. Last but not least, also in code scanning, when you find something, you find it during the development, and then it's much more easier to fix it proactively instead of finding something in production. For example, if you find you don't have a good data retention in place, now to change the schema of a data store is a very painful process. But if you find it during the code scanning, it's a matter of few hours to fix it.
Great. We do have a question. Oh, here we go. Ariel's. How do you identify the PII just through the code?
A very good question. So we have a long mapping of different type of PI data, and on top of it, we also have a mapping of many frameworks for working with data store, with cloud services, with third parties, and AI. And we also when you scan the code, we build a graph representation of all the variable, the classes, the method inside the code, and then we have a good way to ask queries on top of the graph representation. So based on the graph representation and all the mapping, we are asking questions about, okay, which PI data we found in the code, what is the process of the data mapping, the data lineage, and that this specific PI data is going through. And on top of it, we also have additional layer of statistical machine learning model to validate and improve the confidence of our findings. So for example, let's say that we found something related to CVV, which might be related to finance, but might be something totally different. We're also searching and trying to understand the context of the code around the finding. And if we find it related to finance, we increase the confidence that our finding is very accurate.
Great. And Jenna asks, and I don't know if this is showing up in the screen or if I even need to read it, but I'm going to repeat it. Does this require a SaaS-based cloud model?
So the nice thing about our solution is that we can eventually support multiple needs from our customers. So eventually we can ideally run it as a SaaS service. This is our recommendation. It allows us naturally to help with the tweaking and, of course, to push updates. But we do also have some customers that take extra precautions about the sensitivity of the data, so we can also support private cloud, aka on-premise solutions, if needed.
And questions about cost. Sorry, go ahead, Assaf.
So cost is always it's always a good question when you presenting a new technology. I think that one of the nice things about our approach, and we were trying to allude to that during the presentation, is that not only it saves a lot of labor and time, and it allows you to eventually to come up with a better outcome. The fact that we are not requiring a lot of resources to even deploy the solution allows us also to come up with a very competitive pricing. So if you, in example, try to compare it to the two methods that we've said at the beginning, it's one order of magnitude less expensive than typical database scanning. And if you again try to compare it to the super high level and the problematic manual approach of interviews and questionnaires, just calculating all the man hour that are usually involved in such an approach, always again bring you to a much more expensive outcome. To make a long story short, it's a fairly affordable solution. We're usually being asked right after me giving this statement, what is the currency that we're using? So we're charging based on the amount of code that we eventually scan, but we have different packages. But I can say that even the what we call the extra large package is not. You won't need to break the bank eventually in order to use that. That's my message here.
Great. And John asks, how do you treat sensitive data and I guess it's not clear whether it's sensitive data in your system or I guess the sensitive data that you may find in someone's system. I guess how is that treated?
Yeah, very good question. So because we scan the code, we don't collect any PI data except the code, which is very sensitive in some sense, but this is not a regular PI data or PHI data. And we just keep the metadata of our finding and a code snippet. So, and everything is encrypted, and we provide dedicated instance for each customer. So we really care about security, and we do everything to keep the data safe in our environment. Regarding the opposite question, we're not accessing any real PI data of the customers. So there's no need here to treat something because we're just scanning the code.
And Edward has asked, let's see if it's showing. Yep. How can you ensure the information won't leak?
So this is going back to the previous question, because we don't scan data store and because we don't collect PI data, and there's no information here to leak, and there's no PI data here to leak. Having said that, we do clone the code for the scanning. We delete it after the scan, and we keep only the metadata and code snippet for the evidence. And again, everything is secure, encrypted, dedicated instance. And we also do with IP restriction to prevent access to our SAS from unknown, from not well-defined IP addresses. Yeah.
Great. And Jean asks, I think this is going to be our last question because I think we're already a little bit over time, but what regulations are you guys currently supporting?
So we currently support the CPRA and other state regulation in the United States. We also support GDPR. We support PCI DSS, HIPAA, and many other. We are now working also adding additional regulation like Australia and Canada.
The nice thing, and maybe to add to that, the nice thing is that we built something fairly flexible. So in case that there is a demand from a customer for a specific regulation, and or we see something, a question that is coming and becoming very prevalent, usually takes us something like anywhere between 2 weeks to 3 weeks to add an additional regulations where needed. So that's not a barrier for using our product.
Excellent. Well, thank you, Assaf and Dr. Haddad. Really appreciate it. And thank you, everyone, for taking the time out of your day to join us. On screen, you'll see ways you can get in touch. And if you have any questions, please feel free to reach out to myself, Michael Henry. You can always email sales@Drummond Group, which comes to me anyway, and Lior Netzer, who's my colleague with Next.sec AI. Thank you so much. Have a wonderful day.
Thank you so much.